Good morning, everyone.
Good morning, sir.
Okay, so let's start. The last time you just had a little bit of homework, right? You only had to do you had to find the velocity and acceleration for 2 points, right? On a graph. So I hope you would have done it. Okay, very good. All right. So this was the question, right? Okay. So now let's very quickly discuss what's the answer, right? At E, I think you did find it out even at that point, right? Just tell me the answer for E. You have to find the direction of velocity and direction of acceleration for the point E. Yes, good morning, everyone. Yes, we have started to get some correct answers. E is equal to V. Yes. A is equal to minus V. Rehan Khan. Is A equal to minus V? You mean negative I? Okay. Uh, Again, everyone, if you would need the recording, you will have to contact the school first. Okay, I will not be able to give it to you directly. All right, I hope you will understand. Okay, all right then. Fine, that's correct. At the point E, the acceleration is negative, right? At the point E, the acceleration is negative and the velocity is zero, right? Okay, now at F, come on, at F, hurry up. I want the answer for F. At F, everyone, the question is whether the velocity is positive or negative or zero, right? Okay, and what about acceleration? So Rehan Khan, your answer is not proper. All right, fine. I think we have had correct answers, so I'm just going to write it here. It's that at this point F, velocity is negative because you can see clearly that this is going down, right? But here this is a straight line and that means it's not a curve, so the acceleration is zero. All right. So the correct answer is velocity is negative and acceleration is zero. So congratulations to all of you. You did this part very well. Okay. Now, so the yeah, this is what we were talking about the last time, right? That there are different types of XT graph. This is one which is horizontal line, which indicates that the object is not moving at all or it is at rest. All right. Okay. Then uh, this is again a straight line, but it's going up, right? So the velocity is constant, right? Because it's a straight line, the velocity is constant and the velocity is positive, right? And acceleration is of course zero because velocity is constant. Okay, then a similar graph, number three now. Okay, everyone, number three. All right. So this graph number three would be where the xt graph is a straight line once again, but going down like this. All right. Okay, so this is again straight line, right? But here, because this is a straight line, the velocity is constant, and you can see this straight line is going down, right, on the right hand side. It has a negative slope. That's why the velocity is negative and the acceleration is 0. All right. Okay. So if you realize that, if you look at the cases that we have talked about so far, here first one, see the graph is a straight line. Here also it's a straight line. Here as well it's a straight line. So one thing is clear: whenever the xt graph is a straight line, the velocity will be constant. Correct? That is something you should never forget. All right. And by the way, such cases, right? Such cases like this or like this, or even this one, actually, even this one, right? Such cases, they are called uniform motion, right? What is meaning of uniform motion? Uniform motion means motion with constant velocity, right? Motion with constant velocity is called uniform motion. All right. Yeah, no problem with that. Good morning. So everyone remember, probably in lower class, maybe 9th, you would have studied that motion with constant speed is called uniform motion. This is wrong. Okay. So remember, motion with constant speed is not called uniform motion. Okay, motion with constant velocity is called uniform motion. Okay, remember that. Velocity should remain constant. Then, okay, sorry. Velocity should remain constant. Only then, where did it go? Please give me a moment. I don't know which page we are at. I seem to have lost it. Okay. Yeah, so sorry. Fine, let's continue. Can we write motion in a straight line? Motion in a straight line may not be uniform motion. All right. Motion in a straight line may not be uniform motion, everyone. Uniform motion is only when the velocity remains constant. If velocity will change, it is not uniform motion. All right. I hope you remember that velocity is a vector. So it has two parts. Which two? Velocity has two parts. Which two? Answer it. Come on. What are the two parts? That's right. Magnitude and direction. Right? Okay. What is this magnitude called? Modulus? No, Ayush, it is not called modulus. Hey, Harsh, कहाँ पहुंची गया तू? Magnitude is called magnitude. Well done, Preet. Okay, Preet is Preet. Wow. Come on, Preet. No, Ankita, we don't call it a value, right? That value in this case has a very nice name, and that name is speed, right? Magnitude of velocity is called speed, right? Magnitude of velocity is speed. All right. So you see, whenever someone says constant velocity, whenever someone says constant velocity, it means speed is constant and this is also constant, right? Both are constant. All right. Then that is called constant velocity. All right. Yes, Haley. Well done. Okay. So Remember this, constant velocity means speed is, this is ridiculous now. Constant velocity means speed is constant. Not only that, the direction is also remaining the same or constant. All right. So don't forget that. Okay. By the way, a constant velocity is also called uniform velocity, right? A constant velocity means velocity never changes, right? Such thing is also called what? Uniform velocity, right? Such thing is also called uniform velocity. All right. Okay then. So that's what we have, right? So these are the three cases of XT graph. Let's go to more interesting cases now. Number 4. See, I'm drawing all of this. I'm taking so much pain to draw all of these graphs only because it will increase your speed when you solve graph related questions. All right. Okay. Graph related questions are quite common. In fact, in this year's JEE paper also there was one graph related question of this chapter, right? Okay. So let's say now the graph is not, as usual, right? Not a straight line like we have been talking so far. Okay. So let's say that the graph is of this kind of shape, and this shape is a parabola. Okay, I'm telling you that. Now every curve is not a parabola. This is not a parabola, right? Okay, but if the xt graph is a parabola, right? Let's say like this. Okay, if the xt graph is a parabola like this, every curve is not a parabola. Remember, every curve is not parabola. એટલે આમ curve જોઈને સીધું ન કહેતા parabola. All right. You frankly, just by looking at a graph, you cannot say whether it's a parabola or not. Okay, you have to do some measurement. All right, but let's not go into that. Okay, it's not really part of physics. All right. Okay, math students will study what a parabola is exactly. All right. Okay. Yes, Priyansh, every parabola is a curve. Correct. Of course, parabola cannot be straight line, right? This is a straight line. It cannot be a parabola. Okay. So now let's say it's a parabola like this. All right. So what does this indicate? First of all, I would like to ask you about acceleration here. Come on. What information do you get about acceleration from this graph? People, what information do you get about acceleration from? Abe, Sanju, it is all equally divided, right? Physics, chemistry, maths is all equally divided. All right. Okay. And I would request all of you to concentrate on the question at hand. Yes, that's right. Most of you have given correct answer. Uh, acceleration is positive, right? Acceleration is positive. That's correct answer. There's one more thing actually. Look here. There's one more thing. Here it's that because this graph would be a parabola, right? It's a special property. If this graph is a parabola, then acceleration is constant. All right. Why is this constant? Because this graph is a parabola. Now, why is it like that? That we'll know later. Okay. For that, you'll have to attend a few more physics lectures. All right. Then you will know the reason of this connection. All right. So for that time, this will remain a mystery. Right. Okay. So if xt graph is a parabola, acceleration is here like this, positive. You can see it's bowl shape, isn't it? And that's why acceleration is positive, acceleration is constant. So obviously, you could say velocity is increasing, right? Because acceleration is positive, velocity is increasing. I'm not talking about speed. I'm talking about velocity, right? I'm not talking about speed. In fact, what I mean to say is if you look at this here, right? If you look at this here, this is negative velocity, correct? Over here it is zero velocity. And over here it is positive velocity. Agreed? So if you think about speed, right? If you think about speed, let's say that at the point A, at the point B, and at the point C, the velocity was suppose minus 5 meter per second. Suppose, all right, I'm giving example. At B, it is clearly 0 meter per second, and suppose at C, it was 3 meter per second, right? Okay. Now, at which point is the speed maximum? You understand my question? I'm asking you, in such a case, at which point is the speed maximum? At which point? All right, come on. What did I tell you, my dear friends? You should throw your intuition in the dustbin. All right. I have written these are velocities, correct? Agreed? These are velocities. Okay. Speed. What is speed? Can you tell me, everyone? Can you write what is speed? Can you write what is speed? Can you write what is speed? Okay. Now, so many of you have answered it correct. Magnitude of vector is not speed, Heli. Magnitude of velocity is speed, right? Okay, then which has maximum magnitude? A, B, or C? Which has maximum magnitude? A, B, or C? Yes, Ankita, looks like you have a question. Correct. હજી અમુક લોકો C કહે છે. અરે ભાઈ, અરે. This has magnitude or modulus of this is 5. This is a good 0. And this is a good 3. So which is more? Obviously, this one is more, right? This one. All right. So where is the speed maximum? At A. Don't be fooled by minus. This minus is indicating direction. All right. Okay. So that's why, see, that's why I'm writing velocity increases. I'm not saying anything about speed. Speed pela decrease thai, pachi increase thai. So we are not writing about speed. All right. We are only writing about velocity. Velocity increases. Speed nu tame jano. It depends on situation actually. I'm just joking. Speed, it really depends on what's going on really. Okay. My voice isn't coming. Can you hear me, everyone? All right. Iram, I think there's some network problem on your side. Others are able to hear me. Okay. Right. So V is increasing because acceleration is positive, right? That's what is going on here, or vice versa. Okay, let's go to next graph. Number 5. Please, everyone, remember all these cases, right? Please remember all these cases. No, Chintan, most of the students are able to hear me clearly, so I don't think that's a problem. Okay. So I'm now let's draw a parabola once again, but this time it's like this. Okay, it may go below this also, no problem. Okay, so let's say this is once again a parabola, right? But this is clearly not bowl shape. It is which kind of shape? It is bump shape, right? Yes, correct. It is bump shape. So this is a parabola, but that looks like a bump shape. All right. So what is our conclusion? Our conclusion is that acceleration is negative or less than zero. All right. You can also write less than zero. I don't mind. Okay. Then acceleration is constant. Again, why is it constant? It's because this graph is a parabola. The reason, as I said, we'll talk about it later. What do you say about velocity? What would you say about velocity? Velocity will, velocity will, no Resha, that's wrong. Velocity will decrease, yes. Velocity will decrease, right? It may be positive, may be negative, એનાથી કઈ ફરક નથી પડતો. The velocity will decrease. Have a look at this. Suppose I'll draw a tangent here. You see, this is a positive slope. બરાબર ને? Suppose I'll draw a tangent here. This is zero slope. And then if I draw a tangent here, it is negative slope. So velocity was first positive, then it becomes zero, then it becomes negative. It means velocity is decreasing. All right. Okay. Yes, Priyansh, is there a question or something? But again, you cannot say anything about speed, right? Speed will increase for some time and then might decrease also, and or anything else might happen. All right. We will not say anything about speed. Okay. Right. So this is it. Fine. Now these two last cases, how we know that graph is a parabola? Good question, Priyansh. Let me just tell you that. Look here. At this very moment, I have not taught you how to identify a parabola, even in an equation. But the truth is, if someone just draws a graph and like this and asks you, is it a parabola or not, then without 3 or 4 instruments, right, you can never decide whether this is a parabola or not. Okay, so you really don't worry. Normally in questions some information will be given, right? In the question some information will be given. All right, using that information you will be able to know that this is a parabola or not. All right, sometimes they'll just tell you directly. Okay, the question will tell you directly that this is a parabola. Sometimes it will not. Then some other information will be given, and based on that you will be able to identify that it is a parabola. All right, so we'll learn about that when we solve questions. Okay, but your concern, which instrument is used? Routine, right? You need a ruler, you need a compass, right? Okay, and probably you need to draw a couple of circles, a few tangents, like that. If you do such things, right, you will be able to prove or show that this is a parabola, right? That's actually a very practical way of doing it, right? Of course you can also do it with some equations and all that, but we will not worry about the method, right? Because it's all part of maths. Okay, so here that's number 5. Now I want to tell you something about number 4 and number 5. Look at number 4 and number 5, right? In both these cases acceleration is constant. So these cases 4 and 5. Okay, I hope you have space. Unlike me, I don't have any space here. These cases 4 and 5, both of these are called uniformly accelerated motion. I think you understand why it is called like this. The name is clear. Uniformly means constant. All right, so what is constant? Acceleration is constant. Okay, what is constant? The acceleration is constant, right? That's why these are called uniformly accelerated motion. All right, again, any motion with constant acceleration, right? Motion with constant acceleration is called this, uniformly accelerated motion. All right, a word of warning: uniformly accelerated motion is not uniform motion, right? They are different. Uniform motion means constant velocity, right? And this would actually mean constant acceleration. All right, so they are different. Yeah, uniform acceleration means constant acceleration. All right, Falak, I don't think you have any problem with that. Okay, right? So if someone will ask you, what does the graph of uniformly accelerated motion look like? What does the xt graph of uniformly accelerated motion look like? Then the one word answer is a parabola, right? Okay, then, right, it's a parabola. Either may be like this or it may also be like this. That depends on what is acceleration sign. Is it positive? If it's positive, it will look like a ball. If it's negative, it will look like a bump. All right, so that's what we have. Clear? Now let's go to the last case, and typically the useless case, right? Yeah, so that's right, Falak. Okay, so this last case is random in the sense not fixed. Maybe, like this, and then maybe like this, and then suddenly changes to this. Okay, something like this. Okay, right? So any kind of curve, any kind of curve that is not a parabola, right? Any kind of curve that is not a parabola, this would indicate that this is having acceleration which is not constant. Correct? This is having acceleration which is not constant, and velocity also is not constant, right? Both change. That is basically both keep changing, right, from one point to the other. So such motion is called non-uniformly accelerated motion. Okay, I don't think the word is creating problem here. Non-uniformly means not uniform. All right, so that's it. Yes, non-uniform acceleration. Correct. Non-uniform acceleration. Okay, there are people in waiting room. Okay then. So that's it, right? So these are the 6 types of XT graph. Why have we discussed these? So you could solve questions related to graph faster. Must remember all the 6. All right? Okay. जरूर पड़े practice करो. Draw it draw it every day, one time, right? All the 6 graphs every day, one time, maybe for 3 or 4 days. All right, and write these details next to it and do it without seeing. All right, that will help. Okay, so that's it for this part. That's it for the xt graph, right? So before we go to the next topic, again, very quickly. Yes, Gracie? What? How can we say that velocity and acceleration are constant? In which graph are you talking about, Gracie? In which graph are you talking about? Are you talking about the last one, number 6? Array, Gracie, you didn't read it properly, I believe. What is this sign? Equal to, all right? And when I do this, it means not equal to, all right? So I'm saying acceleration is not constant and velocity is also not constant. I'm not saying it is constant, all right? Okay, fine. So before we leave this topic, XT graph, okay, rapid fire round. XT graph. First question, how to find average velocity? Hurry up, people. Hurry up, people. How to find average velocity? જો ક્વેશ્ચન પૂછ્યું ને એટલે બે ત્રણ જણ છોડીને વયા ગયા મીટિંગ લે એવું ચાલે કઈ નો દિવ્યા નો રેશા અરે યાર શું કરો છો people I am not asking you for formula of average velocity which is delta x by delta t. That's okay. I'm asking you if you want to find the average velocity from xt graph, then although this is right, but you should have said slope of chord. Not good. ક્વેશ્ચન સમજવો પડશે બરાબર ફિઝિક્સના ક્વેશ્ચન નીતર તમારું માથું ફેરવી નાખશે લાઇન ઓફ કોર્ડ ન કહેવાય રાહુલ sorry Jaikit. Rahul, your answer was right. Agreed. Right, that was right earlier also. Yes, tan theta, you could also say tan theta, right? Okay, second question. How do you find instantaneous velocity from xt graph? No Kavya, no Har. Yes, that's right. Most of you got it right. Slope of tangent. Please listen to the question carefully. The question is from xt graph, how do you find instantaneous velocity? Then you do it by slope of tangent. Suppose someone would say without xt graph, if you want to find instantaneous velocity without xt graph, right? Without xt graph, if you want to find instantaneous velocity, then how would you do it? Now the answer dx by dt would be correct. I think you understood that, right? Okay, if a graph is already given, you could just draw a tangent and find the slope of tangent and it will do, right? If the graph is not given, then we have to do dx. No, Nandini, that's wrong. Delta x by delta t is not even velocity. Okay. Right, number 3 now. Again from xt graph. How do you find direction of acceleration? No. Hey, acceleration is a vector. Yes, Ankita, well done. No, Nandini. No. Yes, Dhruvanshi, correct. Yes, Jaikit, that's right. Yes, now we are starting to get some kind of. No, Raj. Well done, Princey. Perfect answer. Yes, Ria, well done. No, Resha. Slope gives velocity, doesn't it? Slope of tangent gives velocity. No, Nandini. People, we come to know about direction of acceleration by the curvature, right? Curvature, that is how the graph is curved. Ball or bump, correct? All right, everyone? Okay, direction of acceleration. See, these are the important points that I sent you yesterday. Look at this. Look at this. Look at this. Come on, people. અરે જોઉં જ છું ગ્રેસી બધાનો આન્સર જોઉં છું. All right. But like I said, every time I cannot comment on everybody's answer, right? When you asked the question, I answered it, didn't I? So I'm reading everything. Don't worry about that. Okay, so curvature of xt graph indicates the sign or the direction of acceleration. Please don't forget this. Okay, there. Fine, that's enough. Let's go to next type of graph. Graphs pura thase. It's going to take a long time. Okay. Now we go to next type of graph, velocity time graph. That is VT graph. All right, VT graph. Okay. So how is it different? On y-axis now, you're going to have velocity v, and on x-axis time. Okay. Now see, screenshot of what, Chintan? What do you want screenshot of? What do you want screenshot of? Which graph? No way, Chintan. I'm not going to send the 6 graphs. Not possible, right? If you want to attend the class, you have to be okay, concentrating, and you have to note things down. All right. I'm not going to send all the 6. If you want, you can copy it from your friend, no problem, right? You will not get complete notes of the whole class, right? Nobody will get it, because then you all will become lazy and you will not write anything, and you will not even read anything, right? You'll just save screenshots and sit over there, right? All right. Now, this is yeah. No, don't be sorry. It's fine. Sometimes, we all tend to, uh, we all might have problems. It's possible you may have had connection problems. Then it is that lots of people have connection problems. So then it's going to be a lot of trouble. All right. Okay. So if this is a VT graph, let's say, first of all, let's talk about some properties. Okay, not types of VT graph. All right. Suppose this is some VT graph, maybe like this. Okay, maybe like this. And then I draw a chord, let's say from this point to this point. All right. Then I find slope of chord, right, by finding this angle theta. So here, what will slope of chord give us? That's the question. What is slope of chord equal to in VT graph? Okay. Uh, Nandini, I've just started drawing it. All right, so it's fine, really. Okay, some of you have started giving me answers. Very good, right? Let's see. Let's see. Everyone. Okay, please pause for a while. Pause for a while. Look here. It's that if it is any kind of graph, the slope of chord is always equal to delta y by delta x. I hope you all remember that. We talked about it very early in the chapter, right? I'm sure I'll have it written somewhere. Have a look at this. All right. Correct? This is what you're seeing here, right? If you have a line, then the slope of that line is equal to delta y by delta x, right? Correct? So here, in our situation, we are drawing a VT graph right now. Okay, so let's go back to our page. All right, there we are. Just a minute, I'll just zoom this out because right now Even I'm not able to see the whole thing. Just give it a minute. It will take some time. Okay. Yeah. Let's continue. So right now here on y-axis, what do we have, people? What do we have on y-axis in this graph? What do we have on y-axis? I'm waiting for you, everyone. Come on, take part. What is on the y-axis? Very good, velocity. Right? Y-axis is velocity. So this is equal to delta. Instead of y, I'm writing v divided by. Here on x-axis, what do we have? Deva. What's this? What's this? What is delta v by delta t? What is meaning of delta v by delta t? ચલો ચલો જોઈએ કેટલું યાદ છે તમને. What is delta v by delta t? Average accommodation, there was, I believe autocorrect did that. No, Ria. No, Arkan, that's wrong. No, Dhruvanshi. Okay, the correct answer, people, is average acceleration, right? Come on, please remember the formula, all right? So slope of chord in VT graph gives what? Average acceleration, all right? See, if you realize, this is actually the same as it was here in XT graph. Slope of chord gives what? Average velocity, right? Delta x by delta t. Here similarly it's delta v by delta t. That's called average acceleration. All right, this is average velocity. Here it's average acceleration. Easy, isn't it? Yes. Okay, correct. Okay, Jamin, right. You said that only. I'm not saying everyone was wrong. Okay. Many of you were right, in fact. Okay. Some of you said acceleration. Some of you were saying average acceleration. All right. Aha, Falak, you seem to have got it, right? Yes, so Falak has noted something, and I believe all of you might have also understood that. If you draw a graph and you do something like slope of chord, it's always going to give you average, right? And if you do slope of tangent, if you take slope of tangent, then it's going to give you instantaneous, right? Yes, Haley, your answer was correct. All right, that's perfect observation. Okay, right? So now let's go to the next one. See, just like this is slope of chord in VT graph, average acceleration. Now I think slope of tangent in VT graph will give what? What do you think? What will it give, people? What will it give? Slope of tangent in VT graph. I don't think I should have to explain this. Yes, very good. All answers are right. Well done, people. Well done. Okay, very good. Perfect. Everyone got it right. Yeah. It gives us instantaneous acceleration, but it's okay even if you don't say this, right? So acceleration. Clear? So you should remember this, right? You should remember this. And જો બહુ confusion થશે, let me tell you. અત્યારે તો હમણાં જ ભણ્યા છો, you still remember everything, right? But in maybe few days, you will get confused that whether it was VT graph giving acceleration or XT graph giving acceleration. Please be very careful. All right, so you'll have to revise this a few times. Only then you will be able to remember. Okay. Remember the logic. Okay, see the logic here. Slope of chord is always delta y by delta x, right? And that's why we are getting delta v by delta t, which is average acceleration. If you understand the reason, it's very easy. Similarly, you can write this sentence also, everyone. Why don't you write this? Slope of tangent in any graph, slope of tangent is always equal to dy by dx. If you want, you can write this. It's a useful sentence in my opinion. All right, please write it. In any graph, slope of tangent is always equal to dy by dx, means differentiation. Math students, you can thank me because I've already taught you one whole chapter of maths now. All right. Okay, but yes, the only thing is I hope you'll be able to remember it till you learn it in maths. Then the work of your maths teacher will be reduced, right? He would feel happy that you know it already. Okay, we'll try. That's not valid. You must follow. Trying is not an option. You just have to do it. Okay, so now let's go to the next thing, the types of XT graph. All right. Uh, no, never mind. We'll talk about types later. I just, I just remembered that there's one more thing that I need to tell you about VT graph. Okay, let's continue with that. One more thing about VT graph. Okay, let's start. First of all, I'm going to talk about a simple situation. Okay, right? Let's say that here, let's say that the VT graph is, suppose, horizontal line. All right. Okay, suppose it is a horizontal line. All right. Okay, what does that mean? We'll talk about it. Don't worry. Right. And let's say this velocity is 5 meter per second. Here is origin. 1 second time, 2 second time, 3 second time, and let's say 4 seconds. All right. So do you realize that here the velocity is always 5 meter per second? That is, it is constant. How many of you understood that? Can you please say yes or no? No, acceleration is not constant. All right, velocity is always 5 meter per second, right? Okay, it's not changing at all. Okay, fine. Now then, can you tell me, meaning, what happens here is that v equal to 5 meter per second means, and it's constant, that means that in 1 second object moves 5 meter. Do you agree with this interpretation? This means this, correct? Okay. So then I'm going to ask you this question. In, oh, sorry, just a minute. The page has been changed. Yeah, okay, yeah. Let's continue. So in 4 seconds, how much does the object move? I want to know that. In 4 seconds, how much does the object move? Okay. Some of you, you're giving weird answers. Come on, people. People, look at this. In 1 second, object will move 5 meter. So what that means is, suppose object starts at origin. Okay, this is a person. So after 1 second, the person will be here, right? After one more second, the person will be here. After one more second, the person will be here. And after 4 seconds, the person will be here. Agreed? 5 meter, 5 meter, 5 meter, and 5 meter. Come on. All right. Then why did some of you say 5 meter, some of you said 15 meter, some of you said something else? Come on, people. All right, this is very simple, isn't it? Okay. So in 4 seconds, object moves 20 meters. So that means displacement is 20 meters, correct? Now, what I'm talking about here is as follows. Listen to this. Yes, Dhruvi, do you have a question? So I'm saying that there is one interesting observation. Suppose I will draw a line here at 0 and 4, right? Okay, and then if I find the area between this graph and this x-axis, right? Okay, let's find the area between the graph and x-axis. That area is definitely in the shape of a rectangle, isn't it? Right? So can you tell me what is the area of this rectangle? Look at this rectangle. I want you to tell me what is the area of this rectangle. Formula Berber, what's the value finally? No, Ayushi, wrong formula. What's the answer? Are you sure, Dikshita? Are you sure? Tamanna, are you sure about that? Yes, Dhruvi, what is it? No, Dhruvi, that's not correct. Okay, so the area of the rectangle is obviously L into B, which is equal to 5 into 4, isn't it? That's going to be 20, correct? 20, right? Correct. When the question was, what's the area of rectangle? All right, that's it. Yeah, no problem. It was just, I asked, what is the area of this rectangle? Okay, so now it's 20. Well, is this a coincidence? It's not. Let me tell you that. So we are going to write this line here. Okay, its proof I will give you later. All right. Okay, this is, I've just given you a rough idea of how it works. All right. So write this sentence. This is a very, very important sentence, everyone. Area between VT graph and x-axis gives displacement. Okay, we are actually going to write two sentences here. This is first. Area between VT graph and x-axis gives displacement. Okay, and in the bracket write this as follows. Consider area below axis or area below x-axis as negative. Okay, so that's what we have to write. I will explain this, don't worry about that. Second, don't worry, it's okay, no problem anyone. I've not even explained this. All right, okay, I just want you to write it. When we'll talk about a question, you will understand this better, right? Don't worry about it. But like I said, it's a very important sentence. All right, okay, so second sentence is actually the same. Area between VT graph and x-axis gives path length. Okay, right? But here in bracket you write consider all area as positive. All right. Okay, consider all area as positive. So these are the two sentences. All right. Now okay, we have 2 minutes now, right? So what I'll do is I'll just give you a simple example of the first sentence. Yes, don't worry, Nandini. I've not even started explaining. All right, don't worry about it. I'll still explain. Right. So this is one example of that. It's the easy one. Then next time we'll talk about complicated ones, and you will understand better, or you'll have more details. All right. So right now you see this is VT graph, correct? Okay. So what have we done here? What have we done? We are finding the area which is trapped or sandwiched between what, between the VT graph and the x-axis. All right, so which area are we finding? This one, right? Okay, but then this could go on and on, but we are only finding it for 4 seconds, so that is from here to here. You understood that? So we are finding the area between this VT graph and this axis. All right. So this is a rectangle here. All right. So that area is giving us displacement. Have a look. Yes or no? That area which was between the graph and the x-axis is giving us displacement. How many of you understood that? I'm saying that this area which is between graph and x-axis here, that is 20, and it is exactly the same as this, right? So based on that, I'm claiming this sentence, the first one. I've not completed explanation because we have run out of time. Okay. All right. Okay. So don't worry, we will continue with this the next time, but you should start working on remembering this sentence. All right, both of these. All right, they're more or less same. It's only about negative, positive, right? Okay. So, all right, so we'll continue with this the next time. I will send you the important points step, regarding this. Yes, Ankita, do you have a question? Is it applicable in XT graph? No, Rohan, not applicable in XT graph. Ankita, if you have a question, you could ask it. Yes, this works only for VT graph. All right, that's why we are writing. That's why we are writing it here. Okay. No, Ankita, even in 2 point, it will not be XT graph, right? It has to be VT graph only. Is it for horizontal line? Okay, Ayush. No, everyone, these points are always true. Okay, these points are always true, whether the graph is a straight line or not a straight line, any kind of graph, but it should be VT graph. All right, if the graph is a VT graph, then it will work for any kind of shape. Clear? Okay, that's what I was saying, right? The details, we will talk about the details the next time, right? We were actually going to discuss all of this later. All right, here we have just run out of time. No, Archon, like I said, no, it will work every time. All right, okay, fine. So, well, we'll continue with it tomorrow. Sorry, on Monday. Goodbye, everyone. Chintan, I will answer your question the next time. All right, I have understood your question. I will answer it next time. Okay. Goodbye, everyone.